What if there was an age of human history so old, so distant, so completely erased, that even modern science can't explain where it went, or what it achieved? Imagine standing at the edge of recorded time, looking backward into a darkness so complete that even our most powerful tools can barely penetrate it. Behind us lies everything we know: the rise of Rome, the pyramids of Egypt, the first cities of Mesopotamia. But ahead, stretching into an abyss of millennia, lies something else entirely. A void, a silence, an absence so profound that we've learned to accept it as natural, as if humanity simply didn't exist in any meaningful way before a certain arbitrary point in time. But what if that acceptance is wrong? What if the emptiness we see when we look into deep prehistory isn't emptiness at all, but erasure? What if there were chapters of human achievement, entire epochs of development and discovery, that vanish so completely that we can barely recognize their traces? What if the story we tell ourselves about our origins, the neat progression from primitive hunter-gatherers to agricultural societies to civilizations, is missing something fundamental, something that would change everything we think we know about who we are and where we came from? This isn't a story about certainty. It's a story about gaps, about the spaces between what we know and what we suspect, about the uncomfortable realization that our understanding of human history might be built on foundations far more fragile than we'd like to admit. Because when you start looking closely at the archaeological record, when you examine the timeline of human development with fresh eyes, something strange begins to emerge. Not proof of ancient astronauts or lost continents from fantasy novels, but something subtler and perhaps more unsettling. Evidence that the past is far more complex, far more mysterious, and far less understood than the confident narratives in our textbooks would suggest. The question isn't whether ancient civilizations existed. We know they did. The question is, how ancient, how sophisticated, and what happened to the ones that came before the ones we remember? Tonight, we're going to explore that question. We're going to walk through the evidence, the anomalies, the unexplained gaps in our understanding. We're going to examine the places where the official story doesn't quite fit, where the timeline seems compressed or impossible, where structures appear that shouldn't exist according to our models of human development, and we're going to ask the questions that mainstream archaeology often prefers to avoid. Not because we're looking for easy answers or sensational claims, but because the mystery itself deserves attention. Because the gaps in our knowledge are vast enough to contain entire civilizations, and because somewhere in the darkness of deep time, there might be truths about humanity that we've forgotten we ever knew. So let's begin at the beginning, or rather at the place where the beginning should be, but somehow isn't. The timeline of human history as we're taught it follows a comforting progression. For millions of years, our ancestors were primitive, using simple stone tools, living in small groups, surviving but not thriving. Then, around 12,000 years ago, something changed. Agriculture emerged, settlements formed, civilization began. Within a few thousand years we had cities, writing, mathematics, monumental architecture. The story moves forward from there in a relatively straight line, each innovation building on the last, until we arrive at the modern world. It's a narrative that makes sense. It feels logical. It suggests that human progress is cumulative, that each generation stands on the shoulders of the previous one, gradually climbing toward greater complexity and capability. And for the most part, the archaeological evidence supports this view. But not entirely, because scattered across the world, in places that shouldn't contain them according to this timeline, are structures that don't fit, sites that appear suddenly fully formed, with no apparent developmental history, monuments that demonstrate capabilities we wouldn't expect from the cultures that supposedly built them. And when you start cataloguing these anomalies, when you map them out and examine them closely, a different picture begins to emerge, one that suggests the neat progression we've been taught might be missing some crucial chapters. Take Göbekli Tepe, for instance. Discovered in southeastern Turkey in the 1990s, this site has fundamentally challenged our understanding of prehistoric human capability. The complex consists of massive stone pillars, some weighing up to 20 tons, arranged in circular formations and decorated with intricate carvings of animals: lions, foxes, scorpions, vultures, snakes. The craftsmanship is sophisticated, the planning evident, the execution precise, and it was built approximately 11,600 years ago. That date is crucial because according to the traditional timeline, the people who built Göbekli Tepe shouldn't have been capable of such a feat. They were supposed to be hunter-gatherers, nomadic groups without permanent settlements, without the social organization necessary for large-scale construction projects, without the agricultural surplus that would allow them to support specialized craftsmen and laborers. Yet here was evidence of exactly that kind of organized, sustained effort. Not just a single monument, but an entire complex that would have required decades or even centuries to complete. The site predates Stonehenge by 6,000 years. It predates the pyramids of Egypt by 7,000 years. It predates the invention of writing, the wheel, pottery and metallurgy. And yet the people who built it somehow possessed the knowledge, the tools and the social structure to quarry massive stones, transport them significant distances, carve them with precision, and erect them in carefully planned arrangements that suggest astronomical or ceremonial significance. How? The standard explanation is that Göbekli Tepe represents a transitional phase, that it was built by hunter-gatherers who were just beginning to experiment with sedentary life, and that the effort of building such monuments actually helped catalyze the development of agriculture and permanent settlements. In this view, the site is remarkable, but not inexplicable. It's simply earlier than we expected, pushing back the timeline of human capability, but not fundamentally challenging our understanding of how civilizations develop. But that explanation requires us to accept something extraordinary, that people with no prior experience in monumental construction, no established tradition of stoneworking, no existing models to learn from, somehow created one of the most sophisticated prehistoric sites ever discovered. That they went from making simple stone tools to quarrying and carving 20-ton pillars with no intermediate steps. That they organized labor forces, developed construction techniques, and executed complex architectural plans without any apparent learning curve. It's possible, certainly. Human ingenuity is remarkable, and perhaps the people of Göbekli Tepe were simply more capable than we give them credit for. But it raises a question that echoes across many other sites around the world. What if they weren't starting from scratch? What if they were working from knowledge that already existed, traditions that had been passed down, techniques that had been developed long before? What if Göbekli Tepe isn't the beginning of something, but the remnant of something older? The site itself offers few answers. It was deliberately buried around 8,000 years ago, covered with soil in what appears to have been an intentional act of preservation or concealment. Why would a culture invest so much effort in building such a complex only to bury it? What were they protecting it from? Or what were they trying to ensure would survive? We don't know. The people who built Göbekli Tepe left no written records, no clear indication of their beliefs or motivations. All we have are the stones themselves, standing in silent testimony to capabilities that shouldn't exist according to our models of human development. And Göbekli Tepe is not alone. Across the world, other sites present similar puzzles. In Peru, the fortress of Sacsayhuaman features massive limestone blocks, some weighing over 200 tons, fitted together with such precision that a knife blade cannot slip between them. The blocks are irregular in shape, each one unique, yet they interlock perfectly, a feat of engineering that would be challenging even with modern equipment. The site is attributed to the Inca civilization, which flourished in the 15th century, but the Inca themselves claimed they didn't build the oldest portions. According to their own legends, the massive lower walls were constructed by an earlier people, giants or gods who possessed knowledge the Inca had lost. In Egypt, the Sphinx stares across the desert with a face worn smooth by erosion. But what kind of erosion? Geologists examining the monument have noted that the weathering patterns on the Sphinx and its enclosure are consistent with water erosion, not wind erosion, suggesting that the structure was exposed to significant rainfall over an extended period. Yet Egypt has been arid for thousands of years. The last time the region experienced the kind of sustained rainfall that could produce such erosion was before 7,000 years ago, and possibly much earlier. If those geologists are correct, the Sphinx could be far older than the 4th dynasty of Egypt, when it was supposedly carved. It could predate the pyramids, predate the pharaohs, predate the entire dynastic period of Egyptian history. The Egyptian authorities and most Egyptologists reject this interpretation, arguing that the erosion patterns can be explained by other factors: wind-blown sand, chemical weathering, subsurface water, and they may be right. But the debate itself reveals something important. Our dating methods are not as certain as we often pretend. We rely on context, on associated artifacts, on stylistic comparisons. When a monument stands alone, when it bears no inscriptions and contains no datable materials, we're left guessing. And sometimes those guesses are based more on what we expect to find than on what the evidence actually shows. In Lebanon, the ancient city of Baalbek contains some of the largest worked stones ever used in construction. The Temple of Jupiter sits on a foundation of massive blocks, including 3 stones known as the trilithon, each weighing approximately 800 tons. Nearby in the quarry lies an even larger stone, the stone of the pregnant woman, weighing an estimated 1,000 tons. These blocks were quarried, shaped, transported, and lifted into place with such precision that modern engineers struggle to explain how it was done. The Romans, who built the temple complex, certainly had impressive engineering capabilities, but moving stones of this size would challenge even contemporary technology. Some researchers have suggested that the foundation blocks predate the Roman construction, that they were already in place when the Romans arrived, remnants of an earlier structure built by an unknown culture. Again, mainstream archaeology has explanations. The Romans were master builders, and with enough labour, time and ingenuity, they could have moved the stones using rollers, levers, and ramps. The fact that we don't fully understand their methods doesn't mean those methods didn't exist. And the absence of evidence for an earlier culture at Baalbek doesn't prove one existed. It simply means we haven't found it yet, or that it never existed at all. But the pattern persists. Site after site, across continents and cultures, we find structures that seem to exceed the capabilities we attribute to their builders. We find precision that seems unnecessary for the supposed purpose. We find knowledge of astronomy, mathematics, and engineering that appears suddenly without clear antecedents. And we find legends, persistent, widespread legends, of earlier peoples, lost civilizations, golden ages that ended in catastrophe. Are these legends just myths? Stories invented to explain the impressive ruins left by forgotten ancestors? Or are they memories, distorted by time and retelling, of something that actually happened? The question becomes more pressing when we consider the sheer length of time involved. Modern humans, anatomically modern Homo sapiens, have existed for at least 300,000 years. For most of that time, we're told, they lived as hunter-gatherers, creating little that would survive in the archaeological record beyond stone tools and occasional cave paintings. Then, suddenly, around 12,000 years ago, civilization emerged. But 300,000 years is an almost incomprehensible span of time. It's longer than the entire recorded history of humanity by a factor of 30. It's enough time for civilizations to rise and fall dozens of times over. It's enough time for knowledge to be gained, lost, and gained again. It's enough time for entire epochs of human achievement to vanish without a trace. And that's just modern humans. If we include earlier hominids, Homo erectus, Neanderthals, Denisovans, the timeline extends back nearly 2 million years. 2 million years of tool use, of fire, of language, of culture. 2 million years during which the climate shifted repeatedly. Ice ages came and went. Sea levels rose and fell by hundreds of feet, and entire landscapes were transformed beyond recognition. How much could be hidden in that vast expanse of time? How many chapters of human history could have been written and then erased by the relentless forces of geology and climate? How many civilizations could have flourished during the warm periods between ice ages, only to be destroyed when the glaciers returned? We tend to think of the archaeological record as comprehensive, as if everything that ever existed has left some trace we can find and interpret. But that's not how preservation works. Most organic materials, wood, cloth, leather, paper, decay within decades or centuries. Stone structures can last longer, but even stone erodes, cracks, and crumbles over millennia. And if those structures are buried under ice, submerged beneath rising seas, or pulverized by tectonic activity, they might vanish entirely, leaving no evidence they ever existed. Consider what would remain of our own civilization if it were suddenly abandoned. Within a few centuries, most buildings would collapse. Within a few millennia, even the most durable structures would be reduced to rubble. Within 10,000 years, almost nothing would survive except perhaps some stone monuments, some ceramic fragments, and some metal objects buried in the right conditions. An archaeologist examining the ruins 50,000 years from now might conclude that our civilization was primitive, that we lacked writing or advanced technology, simply because the evidence of those things had decayed beyond recognition. Now imagine that same process repeated over hundreds of thousands of years, through multiple ice ages and interglacial periods, through sea level changes of 400 feet or more, through volcanic eruptions and asteroid impacts and continental drift. How much could be lost? How much could be hidden beneath ice sheets, beneath ocean floors, beneath layers of sediment kilometers thick? The answer is almost everything, and yet we assume that the absence of evidence is evidence of absence. We assume that because we haven't found proof of advanced prehistoric civilizations, they must not have existed. We assume that the timeline we've constructed, based on the fragments that happen to survive in the places we happen to look, represents the full story of human development. But what if it doesn't? What if the story is far older, far more complex, and far more mysterious than we've been willing to consider? What if there was an age before the age we know? A chapter of human history so ancient that even its ruins have been erased, leaving behind only whispers and shadows and the occasional inexplicable monument that doesn't quite fit the narrative we've built. That's the possibility we're exploring tonight. Not as certainty, but as question. Not as proof, but as invitation to look more closely at the gaps in our knowledge, the anomalies in the record, the places where the official story seems incomplete. Because the past is not as settled as we pretend, and the deeper we search, the more the certainties begin to fade, replaced by mysteries that grow larger the more we examine them. If an ancient lost era truly existed, a period of human development sophisticated enough to leave lasting traces but old enough to have been mostly erased, where would we look for evidence? What would survive the passage of tens of thousands of years, the grinding advance and retreat of glaciers, the rise and fall of oceans, the slow but relentless erosion of wind and water? The answer is very little, but not nothing. Stone would survive, if it were massive enough and sheltered enough. Certain metals might persist in the right conditions, and knowledge, encoded in symbols, preserved in myths, passed down through oral traditions, might endure even when the physical structures that housed it had long since crumbled to dust. So let's examine what we have. Let's look at the artifacts and anomalies that don't quite fit, the objects and structures that seem to suggest capabilities beyond what we'd expect from their supposed creators. Not as definitive proof of a lost civilization, but as data points that deserve consideration, pieces of a puzzle that might reveal a larger pattern if we're willing to look. Start with the precision stonework found at sites around the world. At Pumapunku in Bolivia, massive stone blocks are cut with such accuracy that they appear almost machine-made. The surfaces are flat to within fractions of a millimetre. The angles are precise. The blocks feature complex interlocking shapes, H-blocks, I-blocks, that would have required careful planning and execution. Some of the stones show evidence of drilling, with perfectly circular holes that penetrate deep into the rock. The site is dated to around 1,500 years ago, attributed to the Tiwanaku culture. But the Tiwanaku, according to the archaeological record, worked primarily with bronze tools. Bronze is softer than the andesite and diorite stones used at Pumapunku. It's possible to shape hard stone with softer tools. It just requires time, patience, and abrasive materials. But the precision at Pumapunku seems to exceed what we'd expect from such methods. The surfaces are too flat, the angles too exact, the drilling too uniform. Could the Tiwanaku have achieved this level of precision with bronze tools and sand? Perhaps. Human ingenuity should never be underestimated, but it raises the question, why? Why invest so much effort in achieving precision that serves no obvious functional purpose? Why make surfaces flatter than they need to be, angles more exact than structural requirements demand? One possibility is that the precision itself was the point, that it demonstrated mastery, that it served a ceremonial or symbolic function, that it reflected cultural values we don't fully understand. Another possibility is that the precision was necessary for some purpose we haven't identified, some function that required exact measurements and tight tolerances, or perhaps the precision reflects knowledge and techniques that were more advanced than we give the Tiwanaku credit for. Perhaps they possessed tools or methods that haven't survived in the archaeological record. Perhaps they inherited techniques from an earlier culture, preserving and applying knowledge that originated long before their own civilization arose. We see similar precision at other sites. In Egypt, the granite boxes in the Serapeum of Saqqara are carved from single blocks of stone, with internal corners that are perfectly square and surfaces that are flat to within thousandths of an inch. The boxes weigh up to 70 tons each, and they were somehow manoeuvred into underground chambers through passages barely wide enough to accommodate them. The official explanation is that they were sarcophagi for sacred bulls, created during the New Kingdom period around 3,000 years ago. But the precision of the carving seems excessive for that purpose, and the difficulty of installation seems almost deliberately challenging. Some researchers have suggested that the boxes served a different function, perhaps as resonance chambers, or as containers for something more valuable than bull remains. Others have proposed that they're older than the New Kingdom, that they were already in place when the Egyptians discovered them and repurposed them for their own use. Without clear dating evidence, it's difficult to say for certain, but the precision remains, unexplained and remarkable. Then there are the ancient maps. In 1929, a map was discovered in the Topkapi Palace in Istanbul, drawn by an Ottoman admiral named Piri Reis in 1513. The map shows the Atlantic Ocean, the coasts of South America and Africa, and, intriguingly, what appears to be the coastline of Antarctica. But Antarctica wasn't officially discovered until 1813, more than 300 years after the map was drawn, and the coastline shown on the Piri Reis map appears to depict the land beneath the ice, the actual rocky coast of Antarctica, which has been covered by ice sheets for thousands of years. Piri Reis himself noted on the map that he had compiled it from older sources, some dating back to the time of Alexander the Great or earlier. If those sources were accurate, they would have been created at a time when Antarctica's coast was visible, which would place them before the ice sheets formed, potentially 10,000 years ago or more. Mainstream scholars have offered various explanations. Some argue that the supposed Antarctic coastline is actually a distorted depiction of South America, that the map's accuracy is exaggerated, that the resemblance to Antarctica is coincidental. Others point out that medieval and Renaissance cartographers often included speculative landmasses on their maps, filling in blank spaces with educated guesses or mythical territories. The fact that one of these guesses happened to resemble Antarctica doesn't necessarily mean the cartographer had access to ancient knowledge. These are reasonable objections. The Piri Reis map is not definitive proof of anything, but it's part of a larger pattern. Other old maps show similar anomalies, coastlines that seem too accurate for the supposed knowledge of the time, land masses in unexpected places, details that suggest the cartographers were working from sources we don't have access to. The Orontius Phineus map of 1531 also shows Antarctica, depicted as a separate continent with mountain ranges and rivers. The Boaké map of 1737 shows Antarctica divided into two landmasses, which is accurate. Beneath the ice, Antarctica is indeed split by a channel. But how would 18th century cartographers have known that? Again, the explanations are varied. Perhaps the cartographers were extrapolating from limited data. Perhaps they were copying errors from earlier maps. Perhaps the resemblances are coincidental, the result of our tendency to see patterns where none exist. But the questions persist. If these maps are based on older sources, how old are those sources? Who created them? And what happened to the civilizations that possessed the knowledge to chart coastlines with such apparent accuracy? We don't know. The maps themselves offer no clear answers. They're copies of copies, drawn by people who may not have understood the information they were preserving. The original sources, if they existed, are lost. All we have are these tantalizing hints, these suggestions that someone, somewhere, at some point in the distant past, knew more about the world's geography than they should have according to our timeline of exploration and discovery. Then there are the massive stone blocks, the ones that seem almost impossible to move even with modern technology. We've already mentioned Baalbek and Sacsayhuaman, but there are others. In Russia, the bronze horseman statue in St. Petersburg sits on a pedestal carved from a single piece of granite weighing 1,500 tons. It was moved 6 kilometers in the 18th century, using a specially designed platform with metal spheres acting as bearings. A remarkable feat of engineering that required months of planning and hundreds of workers. If moving a 1,500-ton stone was that difficult in the 18th century, with access to metal tools, mathematical knowledge, and organised labour, how did ancient cultures move stones of similar or greater size? The Colossi of Memnon in Egypt, each carved from a single block of quartzite, weigh approximately 700 tons, and were transported over 600 kilometres from their quarry. The obelisks of Egypt, some weighing over 400 tons, were quarried, transported and erected with apparent ease. The Moai of Easter Island, while smaller, were moved across the island and raised onto platforms using methods that remain debated. The standard explanation is that ancient peoples used simple machines, levers, rollers, ramps, sledges, combined with large labour forces and plenty of time, and undoubtedly that's part of the answer. But some of the engineering challenges seem to exceed what we'd expect from those methods. Moving a 700-ton block 600 kilometres across varied terrain, then lifting it upright and placing it precisely, is not a simple task. It requires sophisticated planning, precise execution, and probably techniques we don't fully understand. Does that mean ancient cultures possessed advanced technology? Not necessarily. It might simply mean they were more clever, more patient, and more skilled than we give them credit for. But it does suggest that our assumptions about the capabilities of ancient peoples might be incomplete. It suggests that they might have possessed knowledge of physics, of engineering, of materials, that was more sophisticated than the simple tools they left behind would indicate. And if they possessed that knowledge, where did it come from? Was it developed independently by each culture, or was it inherited, passed down from earlier sources, preserved through traditions that stretched back into the mists of prehistory? Consider the astronomical knowledge encoded in ancient structures. Stonehenge aligns with the summer solstice sunrise. The pyramids of Giza align with the cardinal directions to within a fraction of a degree. The temples of Angkor Wat in Cambodia mirror the constellation Draco as it appeared in 10 to 500 BCE. The Nazca lines in Peru include geometric shapes and animal figures that are only fully visible from the air, along with lines that point to solstice and equinox positions on the horizon. These alignments are not accidental. They demonstrate careful observation of the sky, precise measurement of angles and distances, and sophisticated understanding of astronomical cycles. But why? Why did ancient cultures invest so much effort in encoding astronomical information into their monuments? One explanation is religious or ceremonial, that the alignments reflected beliefs about the cosmos, about the relationship between earth and sky, about the cycles of time and the movements of the gods. Another explanation is practical, that astronomical knowledge was essential for agriculture, for tracking seasons, for maintaining calendars. Both explanations are probably true to some extent, but there's another possibility, one that's more speculative but worth considering. What if the astronomical alignments were a form of record-keeping? What if ancient cultures were encoding information about the sky as it appeared in their time, creating permanent markers that would allow future generations to determine when the structures were built? What if they were deliberately leaving clues, knowing that the precession of the equinoxes, the slow wobble of Earth's axis that causes the positions of stars to shift over thousands of years, would eventually reveal the age of their monuments to anyone with the knowledge to read the signs? If that's the case, then some of the alignments we see might point to dates far older than the supposed construction dates of the structures. The Sphinx, for instance, faces due east, where it would have watched the sun rise on the spring equinox. But due to precession, the constellation that rises with the sun on the spring equinox changes over time, cycling through the zodiac over a period of approximately 26,000 years. Around 10,500 BCE, the spring equinox sun rose in the constellation Leo, the lion. Is it coincidence that the Sphinx has the body of a lion, Or was it built to mark that specific astronomical age? Mainstream Egyptology rejects this interpretation, dating the Sphinx to around 2500 BCE, based on the style of the face and the historical context of the 4th dynasty. But if the body is older than the face, if the Sphinx was recarved at some point given a new head while the body remained unchanged, then the astronomical alignment might point to its true age. We can't know for certain. The evidence is ambiguous, open to multiple interpretations, but the pattern of astronomical alignments across ancient sites around the world suggests that someone at some point possessed sophisticated knowledge of the sky and went to great lengths to encode that knowledge in stone. Why? What were they trying to preserve? And who were they preserving it for? Perhaps they were simply marking time, creating calendars and observatories to serve the needs of their own civilizations. Or perhaps they were doing something more, creating a record that would outlast their own cultures, a message to the future that would survive even if everything else was lost. If the latter, then the message is clear. We were here. We knew things. We built things. We understood the cosmos and our place in it, and we wanted you to know that, even if you've forgotten everything else about us. That's the haunting possibility that emerges when you examine these anomalies closely. Not that ancient peoples were visited by aliens or possessed magical powers, but that they were far more capable, far more knowledgeable and far more sophisticated than our standard narrative allows. That they inherited wisdom from sources we can't trace, preserved it through methods we don't fully understand, and encoded it in monuments that have outlasted their civilizations by thousands of years. And if that's true, then the question becomes, where did that wisdom originate? How far back does the chain of knowledge extend, and what happened to the cultures that first developed it? The answers, if they exist, are buried deep in the past, buried under ice and water and sediment, buried in myths and legends that we've dismissed as fantasy, buried in the gaps between what we know and what we've forgotten. But the search continues, and the deeper we look, the more we realize how much we don't know, how much might be hidden, how much might have been lost. To understand how an entire era of human history could vanish, we need to understand the forces that shape and reshape the Earth's surface. We need to grasp the scale of geological time, the power of climate change, and the fragility of human civilization in the face of planetary catastrophe. Because the Earth is not stable, it never has been. The ground beneath our feet, which seems so solid and permanent, is actually in constant motion, shifting, cracking, rising, falling. Continents drift across the surface of the planet at rates of centimeters per year, colliding and separating over millions of years. Mountains rise and erode, coastlines advance and retreat, and every few thousand years something dramatic happens. A volcanic eruption, an earthquake, a tsunami, a climate shift that transforms entire regions and destroys everything in its path. For most of human history, we've been at the mercy of these forces. We've built our cities on floodplains and coastlines, in the shadows of volcanoes, along fault lines. We've thrived during periods of stable climate and abundant resources, only to face collapse when conditions changed. And when catastrophe struck, when the floods came or the ice advanced or the earth shook, we had no choice but to flee, to adapt, or to perish. Most chose to flee. Some adapted, many perished. And in the process, the knowledge they had accumulated, the structures they had built, the civilizations they had created, all of it could be lost within a single generation. Consider the ice ages. For the past 2.5 million years, the Earth has cycled between glacial and interglacial periods, with ice sheets advancing and retreating across the northern continents. During glacial maxima, ice covered much of North America, Europe and Asia, with sheets up to 3 kilometers thick. Sea levels dropped by as much as 400 feet as water was locked up in the ice, exposing vast areas of continental shelf that are now underwater. The climate was colder, drier, and harsher. Many regions that are habitable today were uninhabitable then. But between the ice ages, during the interglacial periods, the climate was often warmer than it is now. Sea levels were higher, coastlines were different, and the areas that had been covered by ice became habitable again, allowing human populations to expand into new territories. We're currently in an interglacial period, the Holocene, which began approximately 11,700 years ago. Before that, the Earth was in the grip of the last glacial maximum, which lasted from roughly 26,000 to 19,000 years ago. And before that, there was another interglacial period, the Eemian, which lasted from about 130,000 to 115,000 years ago. During the Eemian, global temperatures were slightly warmer than today, and sea levels were 6 to 9 meters higher. Hippos lived in the Thames River, forests covered the Sahara, and humans, anatomically modern humans, were already present, spreading across Africa and beginning to migrate into other regions. What happened during the Eemian? What did humans accomplish during that warm period? We don't know, because almost all evidence from that time has been destroyed. The glaciers of the subsequent ice age scoured the northern continents, grinding away everything in their path. The rising seas of the current interglacial submerged the coastlines where humans would have lived, and the passage of 100,000 years eroded, buried, or obliterated whatever structures or artifacts might have survived. If a civilization had arisen during the Eemian, if humans had developed agriculture, built cities, created art and architecture, almost nothing would remain for us to find. The ice would have crushed it, the seas would have drowned it, time would have erased it, and the Eemian is just one interglacial period. There have been dozens of others over the past 2 million years, each one lasting 10 to 20,000 years, each one providing a window of opportunity for human development. What happened during those periods? What did our ancestors achieve? What knowledge did they accumulate only to lose it when the ice returned? We can't know. The geological record is too incomplete. The evidence is too fragmentary. All we can say with certainty is that humans have been around for a very long time, and that the conditions for civilization have existed repeatedly throughout that time. Whether civilizations actually arose during those earlier periods is a question we may never be able to answer definitively. But the possibility exists, and it's a possibility that becomes more plausible when we consider the catastrophes that have struck even during our current interglacial period. Around 12,800 years ago, something happened. The Earth's climate, which had been warming steadily as the Ice Age ended, suddenly plunged back into near-glacial conditions. Temperatures dropped. Ice sheets that had been retreating began to advance again. The period, known as the Younger Dryas, lasted for approximately 1,200 years before the warming resumed. What caused the Younger Dryas? The leading theory is that a massive influx of fresh water from melting glaciers disrupted ocean currents, particularly the Atlantic meridional overturning circulation, which carries warm water from the tropics to the North Atlantic. When that circulation shut down or weakened, the climate in the Northern Hemisphere cooled dramatically. But some researchers have proposed an alternative explanation, that the Younger Dryas was triggered by a cosmic impact. According to this hypothesis, a comet or asteroid struck the Earth or exploded in the atmosphere around 12,800 years ago, causing widespread fires, ejecting debris into the atmosphere, and triggering the climate shift. Evidence cited includes a layer of sediment from that time period containing high concentrations of platinum, nanodiamonds, and other materials associated with extraterrestrial impacts, as well as a layer of black mat sediment that suggests widespread burning. The impact hypothesis remains controversial. Many scientists argue that the evidence is inconclusive, that the platinum and nanodiamonds can be explained by other processes, and that there's no clear impact crater from that time period. But the debate continues, and new evidence is still being evaluated. Whether the Younger Dryas was caused by an impact or by natural climate processes, the effect on human populations would have been devastating. The sudden return to cold conditions would have disrupted food supplies, forced migrations, and caused widespread hardship. Any civilizations that had begun to develop during the warming period would have faced collapse. And if those civilizations had been concentrated in coastal areas, which is where most human settlements tend to be located, they would have been further threatened by the sea level changes that accompanied the climate shift. When the Younger Dryas ended and the warming resumed, sea levels rose rapidly. Over the course of a few thousand years, the oceans rose by more than 300 feet, drowning vast areas of coastal land. The Persian Gulf, which had been a river valley, became a sea. The Black Sea, which had been a freshwater lake, was flooded by seawater, in what may have been a catastrophic event. The English Channel formed, separating Britain from continental Europe, and coastlines around the world retreated inland, submerging whatever settlements and structures had existed on the exposed continental shelves. If there were civilizations living on those coastlines, and there almost certainly were, because coastlines provide abundant resources and easy transportation, they would have been forced to relocate. Their cities would have been drowned, their fields would have been flooded, and within a few generations the memory of what had been lost might have faded, preserved only in myths and legends of a great flood that destroyed the world. Those flood myths are found in cultures around the world. The story of Noah's Ark in the Bible, the Epic of Gilgamesh in Mesopotamia, the story of Manu in Hindu tradition, the legend of Deucalion in Greek mythology, the tale of Gunyu in Chinese tradition, the Dreamtime stories of Aboriginal Australians. Nearly every ancient culture has some version of a catastrophic flood that wiped out an earlier civilization, leaving only a few survivors to rebuild. Are these myths based on actual events, or are they simply stories invented to explain natural phenomena like seasonal flooding or the presence of marine fossils on mountaintops? The answer is probably both. Floods are common enough that most cultures would have experienced them at some point, and those experiences would naturally be incorporated into their mythology. But the widespread nature of the flood myths and the specific details they share, a sudden catastrophic inundation that destroys the world, a few survivors who preserve knowledge and restart civilization, suggest that they might also preserve memories of real events, not a single global flood, but multiple regional catastrophes that occurred as sea levels rose at the end of the last ice age. If that's the case, then the flood myths might be our only remaining evidence of the civilizations that were lost. The physical structures are gone, drowned beneath hundreds of feet of water. The artifacts have been scattered by currents and buried under sediment. But the stories survived, passed down through oral tradition, distorted and embellished over thousands of years, but still containing a kernel of truth, that there was a time before, a time when the world was different, when people lived in places that are now underwater, and when a great catastrophe forced them to flee and start over. And floods are not the only catastrophes that could erase civilizations. Volcanic eruptions can bury entire regions under ash, as happened to Pompeii and Herculaneum in 79 CE. The eruption of Mount Toba in Indonesia around 74,000 years ago was so massive that it may have caused a volcanic winter lasting years, drastically reducing human populations and creating a genetic bottleneck that's still visible in our DNA. Earthquakes can level cities in minutes. Tsunamis can sweep away coastal settlements. Droughts can turn fertile lands into deserts, forcing populations to migrate or perish. Each of these events has the potential to destroy not just individual settlements, but entire civilizations. And if those civilizations existed during periods when the climate was different, when coastlines were in different locations, when the landscape itself was unrecognizable compared to today, then the evidence of their existence might be impossible to find. We're left with fragments, myths that might be memories, structures that might be older than we think, artifacts that don't quite fit the timeline, and a nagging sense that the story we tell ourselves about human history is incomplete, that there are chapters missing, that the past is deeper and more complex than we've been willing to acknowledge. Because the Earth is old, humans are old, and the forces that shape the planet are powerful enough to erase almost anything, given enough time. So when we look at the gaps in the archaeological record, when we see the sudden appearance of sophisticated structures and knowledge, when we encounter anomalies that don't fit our models, we have to ask, are these anomalies evidence of something we've missed? Or are they just the random noise of an incomplete record, the inevitable result of trying to reconstruct a story from fragments? The honest answer is, we don't know. We can't know, not with certainty. The evidence is too sparse, too ambiguous, too open to interpretation, but the question remains, and it's a question worth asking because the answer, whatever it might be, could change everything we think we know about who we are and where we came from. If an ancient civilization existed and was destroyed by catastrophe, what would the survivors do? How would they preserve their knowledge? How would they ensure that future generations would remember what had been lost? They couldn't rely on written records, paper, parchment, papyrus. All of these decay within centuries at most. Even clay tablets and stone inscriptions erode over time, and they're vulnerable to destruction by fire, flood, and human conflict. If you wanted to preserve knowledge for thousands of years, you'd need something more durable, more resilient, more likely to survive whatever catastrophes the future might bring. You'd need to encode your knowledge in ways that couldn't be easily destroyed, in symbols and structures, in myths and oral traditions, in practices and rituals that would be passed down through generations, even if the original meaning was forgotten. And that's exactly what we see in ancient cultures around the world. Symbols that appear repeatedly across different civilizations, despite no apparent contact between them. Myths that share common themes and motifs. Structures that encode astronomical and mathematical knowledge. Practices that seem to preserve fragments of older wisdom, even when the practitioners no longer understand why they're doing what they're doing. Consider the symbol of the spiral. It appears in prehistoric art across the world, carved into rocks in Ireland, painted on pottery in Greece, etched into cliffs in the American Southwest. The spiral is one of the most common motifs in ancient art, found in cultures separated by thousands of miles and thousands of years. Why? What does it represent? Some researchers suggest it's a natural form, something humans would independently discover by observing shells, whirlpools, or the patterns of growth in plants. Others propose that it has symbolic meaning, representing the cycle of life and death, the passage of time, the journey of the soul. Still others argue that it might encode astronomical knowledge, representing the precession of the equinoxes or the spiral path of the sun through the sky over the course of the year. All of these interpretations might be true to some extent, but the widespread appearance of the spiral and the care with which it was carved and painted suggest that it held deep significance for ancient peoples. It was important enough to preserve, important enough to repeat, important enough to pass down through generations. The same is true of other symbols: the cross, the circle, the triangle, the serpent. All of these appear in ancient art and mythology across cultures. Are they universal archetypes, emerging independently from the human psyche? Or are they remnants of a shared symbolic language, fragments of a system of knowledge that once spanned the world? We can't know for certain. But the possibility is intriguing. If an ancient civilization had developed a sophisticated understanding of astronomy, mathematics, and natural philosophy, they might have encoded that knowledge in symbols that could be easily reproduced and transmitted. Those symbols would have been taught to initiates, preserved in sacred contexts, and passed down through generations. Over time, the original meanings might have been lost or distorted, but the symbols themselves would survive, waiting to be rediscovered and reinterpreted by future civilizations. This is the concept of encoded knowledge, the idea that ancient peoples deliberately preserved information in forms that would outlast their own cultures. And there's evidence that this actually happened, at least to some extent. The Antikythera mechanism, discovered in a shipwreck off the coast of Greece in 1901, is a complex mechanical device dating to around 100 BCE. It contains dozens of bronze gears arranged in a sophisticated system that could predict the positions of the sun, moon, and planets, as well as eclipses and other astronomical events. The device is so advanced that nothing comparable appears in the historical record for another 1,000 years. It demonstrates that ancient Greeks possessed mechanical and astronomical knowledge far beyond what we would have expected from the artifacts that typically survive. If the Antikythera mechanism hadn't been preserved by the unique conditions of the shipwreck, buried in sediment, protected from corrosion by the sea, we would never have known it existed. We would have continued to believe that ancient peoples lacked the knowledge and skill to create such devices, and we would have been wrong. How many other artifacts, how many other examples of ancient knowledge have been lost because they weren't preserved in such fortunate circumstances? How much are we missing because we're only seeing the fragments that happen to survive? The same question applies to ancient texts. The Library of Alexandria, one of the largest and most significant libraries of the ancient world, was destroyed, probably gradually through a combination of fires, wars, and neglect, taking with it hundreds of thousands of scrolls. We know the names of some of the works that were lost: treatises on mathematics, astronomy, medicine, philosophy, history. But we don't know what they contained. We don't know what knowledge was preserved in those texts, what insights ancient scholars had achieved, what discoveries they had made. And Alexandria was just one library. How many others existed and were destroyed? How many texts were written and lost? How much knowledge has vanished simply because the materials it was recorded on decayed or were destroyed? If we're missing so much from the relatively recent past, from civilizations that existed within the last few thousand years, that left extensive written records, that built structures we can still visit, how much more are we missing from the deep past? From periods before writing, before cities, before the civilizations we recognize? The answer is almost everything. We're seeing only the tiniest fraction of what once existed, and that fraction is biased toward the things that were most likely to survive: stone structures, ceramic vessels, metal objects. The things that were most important to ancient peoples, their knowledge, their beliefs, their stories, are largely lost, preserved only in fragmentary form in myths and symbols. But those myths and symbols might contain more than we realize. They might be the encoded remnants of actual knowledge, distorted by time and retelling, but still containing kernels of truth. Take the myth of Atlantis, for instance. Described by Plato in his dialogues Timaeus and Critias, Atlantis was supposedly an advanced civilization that existed 9,000 years before Plato's time, which would place it around 9,600 BCE. According to the story, Atlantis was a powerful maritime empire that controlled much of the Mediterranean and Atlantic regions. It was technologically advanced, wealthy, and militarily strong, but it became corrupt and aggressive, attempting to conquer Athens and other cities. The gods, angered by Atlantis' hubris, destroyed the civilization in a single day and night of catastrophe, sinking the entire island beneath the sea. For centuries, scholars have debated whether Atlantis was a real place or a fictional creation. Plato himself is ambiguous. He presents the story as something told to Solon by Egyptian priests, suggesting it's based on ancient records, but he also uses it as an allegory to illustrate philosophical points about ideal societies and the dangers of corruption. Most historians believe Atlantis was invented by Plato, either as pure fiction or as a distorted memory of real events. Perhaps the Minoan civilization of Crete, which was devastated by a volcanic eruption around 600 BCE, or the city of Helic in Greece, which was destroyed by an earthquake and tsunami in 373 BCE. The details in Plato's account, the concentric rings of water and land, the advanced technology, the sudden destruction, don't match any known archaeological site, and no physical evidence of Atlantis has ever been found. But what if the story preserves a memory of something real? Not necessarily a literal island that sank beneath the sea, but a civilization that existed during an earlier period and was destroyed by catastrophe. The date Plato gives, 9600 BCE, places Atlantis right at the end of the last ice age, during the period of rapid climate change and sea level rise that we know occurred. If there were advanced settlements on the coastlines at that time, they would have been drowned as the seas rose, and the memory of those lost settlements might have been preserved in oral tradition, eventually reaching Plato through the Egyptian priests who claimed to possess ancient records. This is speculative, of course. There's no proof that Atlantis was real, and the burden of proof lies with those making the claim. But the story illustrates how myths might preserve memories of actual events, even if the details have been distorted beyond recognition. The core of the story, a civilization destroyed by catastrophe, lost beneath the sea, is consistent with what we know happened at the end of the Ice Age. The specifics, the concentric rings, the advanced technology, the war with Athens might be embellishments added over thousands of years of retelling. The same pattern appears in other myths. The story of the Tower of Babel describes a time when all humans spoke a single language and attempted to build a tower reaching to heaven. God, displeased by their ambition, confused their languages and scattered them across the earth. The story is usually interpreted as a moral tale about pride and divine punishment, but it might also preserve a memory of a time when human cultures were more unified, when knowledge and language were more widely shared, before some catastrophe or migration event caused populations to disperse and languages to diverge. The Hindu text describes cycles of creation and destruction, with each cycle lasting thousands or millions of years. The current age, the Kali Yuga, is said to be a period of decline, following earlier ages when humans were more virtuous and possessed greater knowledge. These cycles might be mythological, representing philosophical concepts about the nature of time and existence. But they might also reflect actual historical patterns, the rise and fall of civilizations, the accumulation and loss of knowledge, the recurring catastrophes that have shaped human history. The point is not that these myths should be taken literally. They shouldn't. They're stories, shaped by cultural values and religious beliefs, embellished and altered over countless retellings. But they might contain fragments of historical memory, distorted echoes of real events that occurred so long ago that only the stories remain. And if that's the case, then we should pay attention to what those stories are telling us, not as definitive proof, but as clues, as hints about what might have been lost. Because the myths are consistent in certain themes. There was a time before, a golden age, a period when humans possessed knowledge and capabilities that were later lost. That age ended in catastrophe, a flood, a fire, a divine punishment, and the survivors had to start over, rebuilding civilization from the ruins of what came before. These themes appear in cultures around the world, in myths that were recorded independently, with no apparent contact between the cultures that created them. That consistency suggests that the myths might be based on something real, not a single global civilization, but a pattern that repeated across different regions and different time periods. Civilizations arose, achieved a certain level of sophistication, and then collapsed due to catastrophe or internal failure. The survivors preserved what they could, passing down knowledge through oral tradition, encoding it in symbols and structures, hoping that future generations would rediscover what had been lost. And sometimes that knowledge was rediscovered. Sometimes the encoded symbols were decoded, the myths were reinterpreted, the structures were studied and understood. And sometimes that rediscovered knowledge sparked new developments, new innovations, new civilizations that built on the foundations of what came before. But sometimes the knowledge remained hidden. The symbols were copied without understanding. The myths were repeated without comprehension. The structures were admired but not decoded, and the wisdom of the ancients remained lost, waiting for someone with the insight to recognize it for what it was. That's the possibility we're exploring. Not that ancient peoples were more advanced than us, but that they knew things we've forgotten. Not that they possessed magical powers or alien technology, but that they had accumulated knowledge over long periods of time, knowledge that was lost when their civilizations collapsed, and that some of that knowledge might still be recoverable if we're willing to look closely enough at the fragments that remain. The myths are one source of clues, the symbols are another, and the structures themselves, the monuments and megaliths that have survived the passage of millennia, might be the most important source of all. Because those structures were built to last, they were constructed with care and precision, using materials and techniques designed to withstand the forces of nature, and they were often aligned with astronomical phenomena, encoded with mathematical relationships, designed to convey information to anyone with the knowledge to read them. They are messages from the past, and we're only beginning to understand what they're trying to tell us. The idea of a lost prehistoric civilization is not new. It's been proposed by researchers, writers, and theorists for centuries, often dismissed by mainstream academia as pseudoscience or fantasy, and in many cases that dismissal is justified. Many of the claims made about ancient civilizations are based on misinterpretations of evidence, logical fallacies, or outright fabrications. The field is littered with sensational theories that don't hold up to scrutiny. Claims of ancient astronauts, crystal skulls with mystical powers, pyramids built by levitation. But the existence of bad theories doesn't mean the underlying question is invalid. Just because some people have made unfounded claims about lost civilizations doesn't mean the possibility itself should be dismissed. The question deserves serious consideration, based on careful examination of the evidence and rigorous application of scientific methods. So what would it take to prove that an advanced prehistoric civilization existed? What kind of evidence would be convincing? The answer depends on what we mean by advanced. If we're talking about a civilization with technology comparable to our own, with electricity, computers, aircraft, nuclear power, then the evidence would need to be substantial and unambiguous. We'd expect to find clear traces of industrial activity, manufactured materials that couldn't be produced by pre-industrial methods, structures that required advanced engineering. And we don't find those things. There's no evidence of ancient factories, no remnants of advanced machinery, no artifacts that demonstrate technological capabilities beyond what we'd expect from pre-industrial societies. But if we're talking about a civilization that was advanced in different ways, with sophisticated knowledge of astronomy, mathematics, and engineering, with complex social organization, with architectural capabilities that rival or exceed those of later civilizations, then the evidence is more ambiguous. Because those kinds of achievements don't necessarily leave obvious traces. They can be accomplished with relatively simple tools, given enough knowledge, skill, and labor, and the structures they produce can be misattributed to later cultures, especially if those later cultures occupied the same sites and left their own marks. This is where the debate becomes difficult. Because the evidence for a sophisticated prehistoric civilization is not definitive. It consists of anomalies, inconsistencies, and unexplained features that don't quite fit the standard narrative. And those anomalies can be interpreted in multiple ways. Take the precision stonework we discussed earlier. Is it evidence of advanced knowledge and techniques, or is it simply the result of skilled craftsmanship and patient labor? Both interpretations are possible. The precision could reflect sophisticated understanding of geometry and materials, or it could reflect cultural values that emphasize perfection and attention to detail. Without additional context, it's difficult to say which interpretation is correct. The same ambiguity applies to the astronomical alignments. Do they demonstrate advanced knowledge of celestial mechanics, or are they the result of careful observation over many generations combined with trial and error? Again, both are possible. Ancient peoples were certainly capable of sophisticated astronomical observation. We know this from historical records and from the accuracy of their calendars, but whether that knowledge was inherited from an earlier source or developed independently is a question we can't answer definitively. The maps are perhaps the most intriguing evidence, because they seem to show knowledge that shouldn't exist according to the standard timeline, but maps are also notoriously difficult to interpret. Cartographers make errors, they copy from unreliable sources, they fill in blank spaces with speculation. And over time, maps are redrawn, updated and altered, making it difficult to trace their origins. The fact that some old maps show features that resemble Antarctica or other unexpected landmasses doesn't necessarily mean the cartographers had access to ancient knowledge. It might just mean they got lucky, or that we're seeing patterns that aren't really there. So the evidence is inconclusive. It's suggestive, but not definitive. It raises questions, but doesn't provide clear answers, and that's frustrating because we want certainty. We want to know whether a lost civilization existed or not. We want the mystery solved. But maybe the mystery can't be solved, at least not with the evidence currently available. Maybe the best we can do is acknowledge the gaps in our knowledge, recognize the limitations of the archaeological record, and remain open to the possibility that our understanding of human history is incomplete. That doesn't mean we should accept every fringe theory that comes along. It doesn't mean we should abandon critical thinking or scientific rigor. But it does mean we should be willing to question our assumptions, to examine anomalies carefully, and to consider alternative interpretations when the standard explanations don't quite fit. Because the standard narrative of human history, the neat progression from primitive to advanced, from simple to complex, is itself a construction. It's a story we've built from fragments of evidence, filling in the gaps with assumptions and extrapolations. And like any story, it's subject to revision when new evidence emerges, or when old evidence is reinterpreted. In recent decades, that revision has been happening. Discoveries like Göbekli Tepe have pushed back the timeline of human capability, forcing archaeologists to reconsider their assumptions about when and how complex societies emerged. Genetic studies have revealed unexpected patterns of human migration and interbreeding, complicating the simple narrative of human evolution and dispersal. And new dating techniques have challenged the accepted ages of some ancient structures, suggesting they might be older than previously thought. These revisions don't prove that a lost civilization existed, but they do demonstrate that our understanding of the past is constantly evolving, that new discoveries can overturn long-held beliefs, and that the story of human history is far from settled. So what should we make of the anomalies, the unexplained features, the gaps in the record? Should we dismiss them as coincidences or misinterpretations? Or should we take them seriously as potential evidence of something we've missed? The answer is probably somewhere in between. We should be skeptical of extraordinary claims, demanding rigorous evidence before accepting them. But we should also be curious, willing to investigate anomalies and consider alternative explanations. We should recognize that the absence of evidence is not the same as evidence of absence, especially when dealing with time periods so ancient that most evidence would have been destroyed. And we should remember that the past is not as distant as we sometimes think. 12,000 years seems like an eternity, but it's only about 500 generations. If each generation passed down stories to the next, if knowledge was preserved through oral tradition and encoded in symbols and structures, then the memory of events from the end of the last ice age could have survived, distorted, but not entirely lost. That's the possibility that keeps researchers searching, that drives the investigation of anomalies and the reinterpretation of myths. Not the certainty that a lost civilization existed, but the possibility that it might have, the sense that there's something we're missing, something hidden in the gaps between what we know and what we've forgotten. And maybe that's enough. Maybe the search itself is valuable, even if it never yields definitive answers, because the search forces us to question our assumptions, to look more closely at the evidence, to consider perspectives we might otherwise dismiss. It keeps us humble, reminding us that our knowledge is incomplete and our understanding is provisional. And it keeps alive the sense of wonder, the feeling that the past is deeper and more mysterious than we can fully comprehend. That there are stories yet to be discovered, knowledge yet to be recovered, truths yet to be revealed. Because the past is not dead. It's not even past. It's present in the structures that still stand, in the myths that still resonate, in the symbols that still intrigue us. It's present in our DNA, in the languages we speak, in the knowledge we've inherited without knowing where it came from. And somewhere in that past, in the depths of time that we can barely fathom, there might be answers to questions we haven't even thought to ask yet. If we accept the possibility that sophisticated cultures existed in deep prehistory and were destroyed by catastrophe, then we have to confront an uncomfortable question. Could it happen again? The forces that shape the past are still active. The Earth's climate is still changing. Volcanoes still erupt. Earthquakes still strike. Asteroids still pass close to our planet. And human civilization, for all its technological advancement, remains vulnerable to catastrophic events. We like to think we're different from ancient peoples, that our technology and knowledge make us immune to the kinds of disasters that destroyed earlier civilizations. But that's an illusion. We're more vulnerable in some ways because our civilization is more complex, more interconnected, more dependent on systems that can fail catastrophically if disrupted. A major volcanic eruption could disrupt global climate for years, causing crop failures and famines. A large asteroid impact could devastate entire regions and trigger a cascade of secondary effects: tsunamis, fires, climate change. A solar storm could knock out electrical grids and satellite systems, crippling modern infrastructure. And climate change driven by human activity is already causing sea level rise, extreme weather events, and ecological disruptions that could destabilize societies around the world. If any of these catastrophes occurred, how much of our knowledge would survive? We've stored vast amounts of information in digital form, but digital storage is fragile. It requires electricity, functioning hardware, and the knowledge to access and interpret the data. If the infrastructure that supports our digital civilization were destroyed, most of that information would be lost within decades or centuries. Physical books and documents would last longer, but they're vulnerable to fire, water, decay, and deliberate destruction. And even if they survived, they'd be useless without people who could read them, who understood the languages and concepts they contained. The most durable records we have are the ones we've carved in stone: monuments, inscriptions, structures, and even those erode over time, becoming illegible or collapsing into ruins. If our civilization were destroyed tomorrow, what would remain for archaeologists 10,000 years from now? Probably not much. Some stone buildings, some ceramic fragments, some metal objects, and maybe some myths, if any survivors managed to preserve oral traditions through the catastrophe and its aftermath. We'd be in the same position as the hypothetical lost civilizations we've been discussing, reduced to fragments, our achievements forgotten, our knowledge lost. Future archaeologists might look at our ruins and wonder how we accomplished what we did, just as we wonder about the builders of Göbekli Tepe or the pyramids. This is the sobering realization that emerges from contemplating deep time and catastrophic change, that civilization is fragile, that knowledge is easily lost, and that the confidence we have in our own permanence might be misplaced. But there's another side to this realization. If civilizations have risen and fallen before, if knowledge has been lost and rediscovered, then we're part of a larger pattern. We're not the first to achieve sophistication, and we probably won't be the last. Human ingenuity is resilient. Even after catastrophes, survivors rebuild. They preserve what they can, adapt to new conditions, and eventually create new civilizations that build on the ruins of the old. That's the pattern we see throughout history. The Bronze Age collapse around 200 BCE destroyed most of the major civilizations in the Mediterranean and Near East, but new civilizations emerged from the ruins: the Greeks, the Phoenicians, the Israelites. The fall of Rome plunged Europe into centuries of fragmentation and decline, but eventually led to the Renaissance and the modern world. The Black Death killed a third of Europe's population, but the survivors rebuilt and created new social and economic systems. Catastrophes are destructive, but they're also transformative. They clear away old structures and create opportunities for new developments, and they force survivors to adapt, to innovate, to find new ways of doing things. If a lost civilization existed and was destroyed, then we're the inheritors of whatever knowledge they managed to preserve. We're the ones who rediscovered agriculture, rebuilt cities, developed writing and mathematics and science. We're the ones who decoded the symbols they left behind, reinterpreted their myths, and studied their monuments. And if our civilization is destroyed, then future generations will do the same for us. They'll sift through our ruins, puzzle over our artifacts, and try to understand what we achieved and why we failed. They'll preserve what they can, adapt what's useful, and build something new on the foundations we left behind. That's the cycle of civilization: rise and fall, creation and destruction, knowledge gained and knowledge lost. It's been happening for as long as humans have existed, and it will probably continue for as long as we survive as a species. The question is, can we break the cycle? Can we create a civilization that's resilient enough to survive catastrophe, that preserves knowledge in forms that will endure, that learns from the mistakes of the past? Maybe. We have advantages that ancient peoples didn't have. We understand the forces that shape the planet. We can predict some catastrophes and prepare for them. We can store information in multiple forms and multiple locations, reducing the risk that it will be lost. And we can communicate globally, sharing knowledge across cultures and ensuring that no single disaster can destroy everything we've learned. But we also face challenges that ancient peoples didn't face. Our population is larger, our resource consumption is greater, and our impact on the planet is more profound. We've created systems that are efficient but fragile, optimized for normal conditions but vulnerable to disruption. And we've developed technologies that could destroy us. Nuclear weapons, biological agents, artificial intelligence, if we're not careful about how we use them. So the future is uncertain. We might survive and thrive, building on our knowledge and creating a civilization that lasts for millennia. Or we might collapse, victims of our own hubris or of forces beyond our control, leaving only ruins and myths for future archaeologists to puzzle over. Either way, the story continues. Because humans are survivors. We've endured ice ages and droughts, plagues and wars, catastrophes natural and self-inflicted. We've lost knowledge and regained it, built civilizations and watched them fall, started over again and again. And through it all we've preserved something essential: the drive to understand, to create, to build, to pass on what we've learned to the next generation. That drive is what makes us human. It's what allowed our ancestors to survive when other species went extinct. And it's what will carry us forward, whatever challenges we face. So when we look at the ruins of ancient civilizations, when we contemplate the possibility of a lost knowledge and forgotten achievements, We're not just looking at the past, we're looking at ourselves. We're seeing the pattern that we're part of, the cycle that we're continuing, and we're asking the same questions that ancient peoples must have asked when they looked at the ruins of civilizations that came before them. What happened? What was lost? And what can we learn from it? Those questions don't have easy answers, but they're worth asking because they force us to think about who we are, where we came from, and where we're going. They remind us that our civilization is not inevitable, that our knowledge is not permanent, and that the future is not guaranteed. But they also remind us that we're part of something larger than ourselves, a story that stretches back into the depths of time and forward into an unknown future, a story of human achievement and human failure, of knowledge gained and knowledge lost, of civilizations that rise and fall like waves on an endless ocean. And somewhere in that story, in the gaps between what we know and what we've forgotten, there might be truths that could change everything. As we reach the end of this journey through deep time and forgotten history, we're left with more questions than answers. And maybe that's appropriate, because the past is not a puzzle to be solved, with all the pieces fitting neatly together to form a complete picture. It's a mystery, vast and complex, with most of the pieces missing and the remaining fragments open to multiple interpretations. We've explored the evidence for a lost era of human history, the anomalous structures, the unexplained artifacts, the myths and legends that hint at forgotten knowledge. We've examined the forces that could erase entire civilizations, leaving almost no trace for future generations to find. And we've considered the possibility that our understanding of human history is incomplete, that there are chapters missing from the story we tell ourselves about our origins. But we haven't proven anything. We can't prove that an advanced prehistoric civilization existed, because the evidence is too fragmentary and too ambiguous. We can't prove that ancient peoples possessed knowledge that was later lost, because knowledge leaves few traces in the archaeological record. And we can't prove that the myths and legends of ancient cultures preserve memories of real events, because myths are by nature symbolic and metaphorical, not literal historical accounts. What we can say is this: the possibility exists. The gaps in our knowledge are large enough to contain entire civilizations. The forces that shape the Earth are powerful enough to erase almost any evidence of human activity, given enough time, and the patterns we see in the archaeological record, the sudden appearance of sophisticated structures, the widespread distribution of similar symbols and myths, the unexplained capabilities of ancient peoples, are consistent with the hypothesis that knowledge was preserved and transmitted across vast spans of time, even when the civilizations that created that knowledge had long since vanished. That doesn't make the hypothesis true, but it makes it worth considering, worth investigating, worth keeping in mind as we continue to explore the past and uncover new evidence. Because the past is not static. It's constantly being revised as new discoveries are made, as new techniques are developed, as new perspectives are brought to bear on old questions. What we believe today about human history might be overturned tomorrow by a single discovery. A new site, a new artifact, a new interpretation of existing evidence. And that's exciting. It means the story is not finished. It means there are still mysteries to solve, still questions to answer, still truths to uncover. It means that the past is alive, in a sense, still revealing itself to us, still offering up its secrets to those patient and curious enough to search for them. So what should we take away from this exploration? What lessons can we draw from the possibility of a lost era, from the gaps in our knowledge, from the mysteries that remain unsolved? First, humility. We should recognize that our understanding of the past is incomplete and provisional, that what we know is dwarfed by what we don't know, and that certainty is often an illusion. The confident narratives we construct about human history are built on fragmentary evidence and filled in with assumptions. They're useful, they're necessary, but they're not absolute truth. Second, curiosity. We should remain open to new evidence and new interpretations, willing to question our assumptions and revise our beliefs when the data demands it. The anomalies and unexplained features we've discussed might turn out to be nothing, or they might turn out to be clues to something profound. We won't know unless we investigate them seriously and rigorously. Third, wonder. We should preserve the sense of mystery, the feeling that the past is deeper and stranger than we can fully comprehend, because that sense of wonder is what drives discovery. It's what pushes us to look beyond the accepted explanations, to dig deeper, to ask the questions that others dismiss as unnecessary or unproductive. Without wonder, science becomes mere cataloguing. Without mystery, history becomes a closed book, already read, already understood, with nothing left to reveal. And the truth is, we need that sense of wonder now more than ever. We live in an age of unprecedented access to information, where answers to almost any question are available within seconds. But that ease of access can create a false sense of completeness, a belief that if something were true, we would already know it, that if a lost civilization had existed, we would have found it by now, that if there were gaps in our understanding, they would be obvious and acknowledged. But knowledge doesn't work that way. Discovery is not a linear process where each generation simply adds to what came before. It's messy, chaotic, full of wrong turns and abandoned theories and evidence that gets overlooked because it doesn't fit the prevailing paradigm. Sometimes the most important discoveries come from revisiting old questions with new tools, or from taking seriously the anomalies that everyone else has learned to ignore. The sense of wonder keeps us searching. It reminds us that the universe is under no obligation to make sense to us, that reality is often stranger than our theories predict, and that the past might hold surprises we haven't even imagined yet. So what does this mean for how we approach human history? How should we think about our place in the vast sweep of time? The conventional narrative places us at the pinnacle of human achievement. We are, according to this view, the most advanced, most sophisticated, most knowledgeable humans who have ever lived. Our technology surpasses anything that came before. Our understanding of the universe exceeds that of all previous generations. We are the culmination of a long, steady climb from primitive beginnings to modern enlightenment, and in many ways this is true. We have achieved things that would seem like magic to our ancestors. We've split the atom, mapped the human genome, sent machines to other planets, connected the entire world through invisible networks of information. Our scientific knowledge is vast and growing. Our technological capabilities are extraordinary. But this narrative also contains a dangerous assumption, that progress is inevitable, that advancement is linear, that each generation necessarily knows more and can do more than the one before. It assumes that if something were possible, we would have done it, and if we haven't done it, it must not have been possible for anyone else either. This assumption blinds us to certain possibilities. It makes it difficult to imagine that previous cultures might have possessed knowledge or capabilities that we've lost. It makes us dismiss evidence that doesn't fit our timeline. It makes us confident in our understanding when perhaps we should be more cautious. What if we're not the pinnacle? What if we're just one point on a much longer curve, a curve that has risen and fallen multiple times over tens of thousands of years? What if human capability has waxed and waned with the cycles of climate and catastrophe, with civilizations rising during favourable periods and collapsing when conditions deteriorated? This doesn't mean ancient peoples had computers or spacecraft. It doesn't require us to imagine impossible technologies or alien intervention. It simply means recognizing that human ingenuity, human creativity, human problem-solving ability, these things are not unique to our era. They're fundamental aspects of what it means to be human, and they've been present for as long as anatomically modern humans have existed. A person living 12,000 years ago had the same brain capacity we have, the same potential for abstract thought, for planning, for innovation, for artistic expression, the same ability to observe the world carefully, to recognize patterns, to develop sophisticated understanding of natural phenomena, the same capacity for wonder and curiosity that drives us today. What they lacked was not intelligence or capability, but accumulated knowledge and the infrastructure to preserve and transmit that knowledge across generations. And that's precisely what would be lost in a catastrophic collapse. Not the human potential, but the cultural and technological achievements built upon that potential. So when we look at the past, we should see not primitive ancestors stumbling towards civilization, but fully human beings facing the same fundamental challenges we face. How to survive, how to thrive, how to understand the world, how to create meaning and beauty and lasting works. Some of them succeeded in ways we're only beginning to appreciate. Some of them failed, and their failures were so complete that we've forgotten they ever tried. That's a humbling perspective. It suggests that our own achievements, as impressive as they are not guaranteed to endure. It suggests that we're part of a longer story, one that extends far back before recorded history and will continue long after we're gone. It suggests that the question is not whether we're the most advanced humans who ever lived, but whether we'll be wise enough to ensure that our knowledge survives for those who come after. This brings us to a fundamental tension in how we approach these questions, the balance between skepticism and open-mindedness. Skepticism is essential. It's the foundation of scientific inquiry, the tool we use to separate truth from fiction, evidence from speculation, knowledge from wishful thinking. Without skepticism, we'd believe every claim, accept every theory, chase every phantom. We'd waste time and resources investigating ideas that have no merit, and we'd never develop reliable knowledge about the world. But skepticism can also become a barrier to discovery. When it hardens into dogma, when it refuses to consider evidence that challenges established views, when it dismisses questions as unworthy of investigation simply because they seem unlikely, then skepticism stops being a tool for finding truth and becomes a defense mechanism for protecting existing beliefs. The history of science is full of examples where the skeptics were wrong. Continental drift was dismissed as impossible until the evidence became overwhelming. The existence of meteorites was denied by the French Academy of Sciences because rocks couldn't fall from the sky. The idea that bacteria could cause ulcers was ridiculed until 2 researchers proved it and won a Nobel Prize. In each case, the skeptics had good reasons for their skepticism. The claims seemed to violate known principles, the mechanisms were unclear, the evidence was initially weak, but their skepticism prevented them from seeing the truth. The challenge is to be skeptical without being closed-minded, to demand evidence without dismissing possibilities, to maintain high standards for proof while remaining open to surprises. When it comes to the possibility of a lost civilization, this balance is particularly difficult to strike. The evidence is fragmentary and ambiguous. The claims often come from researchers outside the mainstream, sometimes mixed with less credible ideas. The implications are profound, challenging fundamental assumptions about human history. It's easy to see why many academics are skeptical, even dismissive. But dismissal is not the same as disproof. Saying there's no evidence is not the same as saying, we've looked everywhere and found nothing. And when the evidence we do have, the precision of ancient stonework, the sophistication of astronomical alignments, the anomalies in dating, the persistent myths of lost civilizations, when all of this is simply ignored or explained away without serious investigation, then skepticism has crossed the line into something else. What we need is rigorous open-minded investigation. We need researchers who are willing to take these questions seriously, to apply the full range of modern scientific tools to the evidence, to follow the data wherever it leads. We need funding for research that explores these possibilities, not just research that confirms what we already believe. We need academic environments where asking unconventional questions doesn't end careers. Because the truth is, we don't know. We don't know what happened 12,000 years ago, or 20,000 or 50,000. We have theories, we have models, we have narratives that fit the evidence we've found. But the evidence is incomplete, and the narratives are provisional. They're the best explanations we have right now, but they're not final answers. And if we're not willing to question them, if we're not willing to investigate the anomalies and explore the alternatives, then we're not doing science, we're defending a belief system. So what questions should researchers be asking? What lines of investigation might yield the most insight? First, we need to focus on the places we haven't looked. The vast majority of archaeological research has concentrated on areas that are easily accessible and obviously promising. The river valleys where we know civilizations arose, the regions where we've already found significant sites. But if we're looking for evidence of earlier cultures, we need to search in places that would have been attractive during different climatic periods. The continental shelves are the obvious target. During the last ice age, when sea levels were hundreds of feet lower than today, these areas were dry land. They would have been prime real estate, coastal plains with access to both marine and terrestrial resources, temperate climates, river mouths that would have been natural gathering places. If there were sophisticated cultures during the Ice Age, this is where they would have lived. And now those areas are underwater, covered by hundreds of feet of ocean, blanketed with sediment, largely unexplored. We've barely begun to survey these submerged landscapes. The few underwater archaeological sites we've found, like the structures off the coast of India and Japan that some researchers believe are man-made, hint at what might be waiting to be discovered. Modern technology makes this exploration possible. Side-scan sonar can map the ocean floor in detail. Remotely operated vehicles can investigate promising features without the need for human divers. Underwater excavation techniques have advanced significantly. What we need is the will to look and the funding to support systematic surveys of the most promising areas. Second, we need to apply new dating techniques to old sites. Radiocarbon dating has been the standard for decades, but it has limitations. It only works on organic materials, it becomes less accurate beyond about 50,000 years, and it can be contaminated by later materials. But there are other methods now available. Optically stimulated luminescence can date when sediments were last exposed to sunlight, providing ages for the layers surrounding artifacts. Cosmogenic nuclide dating can determine how long rock surfaces have been exposed to cosmic rays, potentially dating when stones were quarried or carved. Archaeoastronomy can provide independent age estimates based on the alignment of structures with celestial phenomena that change over time due to precession. These techniques should be applied systematically to sites that show anomalous features. The precision stonework, the astronomical alignments, the sophisticated engineering. Not to prove they're older than currently believed, but to test that assumption rigorously. If the conventional dates are correct, the new techniques will confirm them. If they're not, we'll learn something important. Third, we need to take the ancient maps seriously. The Piri Reis map, the Orontius Phineus map, and others show features that shouldn't have been known when they were drawn. The standard explanation is that they're based on earlier maps, but that just pushes the question back. Where did those earlier maps come from? Modern satellite imaging and ground-penetrating radar can verify whether the features shown on these maps actually exist beneath the ice or sediment. If they do, if Antarctica's coastline under the ice sheet matches the coastline shown on a 16th century map, then we have to explain how that information was obtained. The explanation might not require a lost civilization. Perhaps there are other ways the information could have been preserved or inferred, but we won't know unless we investigate. Fourth, we need to study the genetic and linguistic evidence more carefully. Modern humans left Africa at least 70,000 years ago, possibly earlier. They spread across the world, adapted to different environments, developed different cultures. But the genetic record shows something interesting. There are bottlenecks, periods, when human populations crash dramatically, followed by expansions. The most significant bottleneck coincides with the Younger Dryas, the period of rapid climate change that began around 12th Alventhias and 800 years ago. Human populations declined sharply. Many large animal species went extinct. Something catastrophic happened. Understanding exactly what happened and how human populations responded might shed light on whether there were sophisticated cultures that collapsed during this period. Linguistic evidence is also suggestive. Some researchers have identified deep connections between language families that are supposed to be unrelated, suggesting they might have diverged from a common ancestor much earlier than currently believed. If true, this would imply that complex language, and by extension complex culture, existed much earlier than the conventional timeline suggests. Fifth, we need to investigate the myths and legends more systematically, not by taking them literally, but by recognizing that they might contain kernels of historical truth, distorted by time and retelling but not entirely invented. Comparative mythology has identified common themes that appear in cultures around the world: the flood, the lost golden age, the destruction and renewal of the world, the culture heroes who brought knowledge to humanity. These similarities might be coincidental, or they might reflect common human psychological patterns, or they might be distant memories of actual events. Distinguishing between these possibilities requires careful analysis. We need to map the distribution of these myths, trace their evolution over time, look for correlations with archaeological and geological evidence. We need to ask, are there patterns that suggest these stories are based on real events? Are there details that couldn't have been invented, that point to actual historical occurrences? This kind of research is difficult and often speculative, but it's not impossible. And if the myths do contain historical information, they might point us toward evidence we wouldn't otherwise think to look for. The psychological and philosophical implications of these questions are profound. What does it mean if we're not the first? What does it change if human civilization is much older than we thought? On one level, it changes nothing. We're still here, still facing the same challenges, still trying to build a better future. The practical realities of our lives don't depend on what happened 12,000 years ago. But on another level, it changes everything. It changes how we think about ourselves, our place in time, our relationship to the past and future. It changes the story we tell about who we are and where we came from. The conventional narrative is one of progress, of steady advancement from primitive beginnings to modern sophistication. It's a comforting story. It tells us that we're special, that we've achieved something unprecedented, that we're moving forward toward an ever better future. It gives meaning to our struggles and validates our achievements. But it's also a story that makes us complacent. If progress is inevitable, if we're guaranteed to keep advancing, then we don't need to worry too much about the future. We don't need to take seriously the possibility of collapse, of losing what we've built, of having to start over. We can assume that our knowledge will endure, that our civilization will continue, that future generations will remember us and build upon what we've created. The alternative narrative is less comforting, but perhaps more realistic. It suggests that we're part of a cycle, that civilizations rise and fall, that knowledge can be lost as well as gained, that progress is not guaranteed. It suggests that we're not special, not unique, not the culmination of history, but simply one more chapter in a much longer story. This is a humbling realization, but it's also an empowering one. Because if civilizations can fall, then we need to take seriously the work of preservation, of ensuring that our knowledge survives, of building systems that can withstand catastrophe. If we're not guaranteed a future, then we need to work harder to create one. It also changes how we think about the past. Instead of seeing ancient peoples as primitive ancestors who were less capable than us, we might see them as fully human, facing challenges as great as ours, achieving things we can barely understand. We might approach their monuments and artifacts with more respect, more curiosity, more willingness to learn from them, and it raises profound questions about meaning and purpose. If civilizations rise and fall, if knowledge is gained and lost, if the cycle repeats over and over, then what's the point? Why build? Why create? Why strive for something better, if it's all going to be lost eventually? The answer, perhaps, is that the striving itself is the point, that the creation of beauty and knowledge and meaning is worthwhile even if it's temporary, that we build not for eternity, but for now, for ourselves and for the generations immediately, following us, and we hope that something of what we create will endure, will be found by those who come after, will inspire them to build their own civilizations and create their own meaning. This is the message encoded in the monuments, perhaps. Not, look how great we were, but we were here, we existed, we created, we mattered. It's a message that transcends time, that speaks to something fundamental about the human condition. We want to be remembered. We want our existence to mean something. We want to leave traces that will outlast us. And if there were civilizations before us that left such traces, if we're now finding and interpreting those traces, then in a sense they've succeeded. They've reached across thousands of years to touch us, to make us wonder, to make us question. They've become part of our story, even if we don't fully understand theirs. That's a kind of immortality, perhaps the only kind that's really possible. Not living forever, but creating something that endures, that continues to have meaning and impact long after the creators are gone. So what kind of evidence would be most convincing? What would it take to prove that a lost civilization existed? The challenge is that we're looking for something that, by definition, was almost entirely destroyed. We're looking for traces of a culture that collapsed so completely that it left almost nothing behind. We're looking for needles in a haystack, except the haystack is the entire world, and the needles have been corroding for 12,000 years. The most convincing evidence would be something that couldn't be explained any other way. An artifact that's clearly manufactured but predates the supposed beginning of civilization. A structure that's definitively dated to the Ice Age but shows sophisticated engineering. A written record that describes events or knowledge that shouldn't have been possible at the time it was created. But finding such evidence is extraordinarily difficult. Organic materials decay. Stone structures can be reused or attributed to later cultures. Dating techniques have margins of error. And there's always the possibility of contamination, misinterpretation, or fraud. What we're more likely to find is accumulating circumstantial evidence. Not a single smoking gun, but a pattern of anomalies that becomes harder and harder to explain away. Multiple sites showing similar features, multiple dating techniques suggesting similar ages, multiple lines of evidence pointing in the same direction. This is how scientific revolutions usually happen. Not with a single dramatic discovery, but with a gradual accumulation of evidence that doesn't fit the existing paradigm, until eventually the weight of that evidence forces a paradigm shift. For the lost civilization hypothesis, the most promising evidence would probably come from several sources converging. Underwater archaeology, discovering structures on the continental shelves that are clearly man-made and clearly ancient. Not just one or two ambiguous features, but multiple sites showing consistent patterns of construction and dating to the end of the Ice Age. Advanced dating techniques applied to existing sites confirming that some of them are older than currently believed, or showing that the precision stonework predates the cultures we've attributed it to. Genetic and linguistic analysis revealing deeper connections between human populations, suggesting more complex patterns of migration and cultural exchange than the current models predict. Geological evidence confirming that catastrophic events occurred at the end of the Ice Age, whether impacts, floods, volcanic eruptions, or some combination, that would have been severe enough to destroy civilizations and force survivors to start over. Analysis of ancient texts and myths, identifying specific details that correlate with archaeological or geological evidence, suggesting they contain historical information rather than pure invention. None of these alone would be conclusive, but together they would create a compelling case that something significant happened at the end of the Ice Age, that human cultures at that time were more sophisticated than we've assumed, and that the conventional timeline of civilization needs to be revised. The key is that the evidence needs to be rigorous, reproducible, and peer-reviewed. It needs to withstand skeptical scrutiny. It needs to be published in legitimate scientific journals and subjected to the full process of scientific validation. Anything less will be dismissed, and rightly so. This is why the work needs to be done by credentialed researchers using accepted methods. It's why funding is so important. It's why we need academic institutions to take these questions seriously, rather than treating them as fringe topics, unworthy of investigation. Because if the evidence is there, if it can withstand rigorous examination, then it will eventually be accepted. Science is self-correcting. It might take time, it might face resistance, but ultimately evidence wins. The truth emerges. The question is whether we're willing to look for it. Technology is giving us unprecedented tools to search for evidence of lost history. Tools that didn't exist even a decade ago. Tools that are revealing things we never could have found before. LiDAR, light detection and ranging, has revolutionized archaeology. It uses laser pulses to create detailed three-dimensional maps of the ground surface, penetrating vegetation and revealing features that are invisible to the naked eye. In the past few years, LiDAR surveys have discovered thousands of previously unknown structures in the jungles of Central America, revealing that Maya civilization was far more extensive than anyone realized. The same technology could be applied to other regions. Dense forests might hide structures we've never found. Deserts might contain features buried under sand. Even areas that have been surveyed before might reveal new details when examined with LiDAR. Ground-penetrating radar is another powerful tool. It can detect buried structures without excavation, revealing the layout of ancient sites and identifying promising areas for further investigation. Combined with other remote sensing techniques, magnetometry, electrical resistivity, thermal imaging, it's possible to create detailed maps of what lies beneath the surface before ever breaking ground. Satellite imaging has also advanced dramatically. High-resolution imagery can reveal subtle features in the landscape, ancient roads, field systems, building foundations that are invisible from ground level. Multispectral imaging can detect differences in vegetation or soil that indicate buried structures. Synthetic aperture radar can penetrate clouds and vegetation to map the ground surface. These technologies have already led to significant discoveries. In 2015, satellite imagery revealed a massive network of previously unknown settlements in the Amazon. challenging the assumption that the rainforest was sparsely populated before European contact. In 2018, ground-penetrating radar discovered a huge ceremonial complex near Stonehenge that had been completely hidden. In 2020, LiDAR revealed the largest and oldest Maya structure ever found, dating to around 1000 BCE. If these technologies can reveal so much about civilizations we already knew existed, imagine what they might reveal about civilizations we don't know about. Imagine what might be hidden in the places we haven't looked, waiting to be discovered by someone with the right tools and the willingness to search. DNA analysis is also providing new insights. Ancient DNA extracted from bones and teeth can tell us about population movements, genetic relationships, and even diseases and diet. It's revealing that human history is far more complex than we thought, with multiple waves of migration, extensive interbreeding between different populations, and genetic lineages that don't match the simple models we've constructed. Recent studies have found evidence of ghost populations, groups of ancient humans who left no archaeological trace, but whose DNA persists in modern populations. These ghost populations interbred with our ancestors, contributing genes that are still present today, but we have no idea who they were, where they lived, or what their cultures were like. They're invisible in the archaeological record, known only through their genetic legacy. This raises an obvious question. If entire populations can be invisible to archaeology but detectable through genetics, what else might be invisible? What other groups, what other cultures, what other achievements might have left no trace except in our DNA? Environmental DNA is another emerging field. DNA persists in sediments, in ice cores, in the soil itself. By analysing ancient environmental DNA, researchers can reconstruct past ecosystems, identify what plants and animals were present, even detect human activity through the presence of domesticated species or changes in vegetation patterns. This technology could potentially identify areas where humans were active during the Ice Age, even if no artefacts have been found. It could reveal whether certain regions were inhabited earlier than we thought, or whether human impact on the environment was more extensive than the archaeological record suggests. Chemical analysis of artefacts is also revealing new information. Residue analysis can identify what substances were stored in ancient pottery, what foods were prepared, what materials were used in manufacturing. Isotope analysis can determine where materials came from, tracing trade networks and population movements. Where pattern analysis can show how tools were used, revealing details about ancient technologies and practices. All of these techniques are becoming more sophisticated, more sensitive, more capable of extracting information from even the smallest traces, and they're being applied to more and more sites, revealing details that previous generations of archaeologists never could have discovered. The technology exists, the methods are proven. What we need now is the will to apply them to the questions we've been discussing, to search the continental shelves systematically, to redate the anomalous sites, to analyse the genetic and environmental evidence for signs of earlier complexity, to take seriously the possibility that we might find something unexpected. Because the tools are there, the evidence might be there. We just need to look. So why does this matter? What changes if we're wrong about the timeline of human civilization? On a practical level, perhaps not much. Our daily lives don't depend on what happened 12,000 years ago. Whether civilization began in 4000 BCE or 12,000 BCE doesn't change the fact that we need to go to work, pay our bills, take care of our families, but on a deeper level it matters enormously. Because the stories we tell about the past shape how we think about the present and future. They shape our sense of who we are, what we're capable of, what's possible. If we're the first civilization, if we're the pinnacle of human achievement, if progress is inevitable and linear, then we can be confident about the future. We can assume that we'll keep advancing, keep improving, keep building on what we've created. We can assume that our knowledge is secure, that our achievements will endure, that future generations will remember us and surpass us. But if we're not the first, if civilizations have risen and fallen before, if knowledge can be lost as well as gained, then we need to be more careful. We need to think harder about preservation, about resilience, about how to ensure that what we've learned doesn't disappear if catastrophe strikes. This has practical implications. It suggests we should be investing more in preserving knowledge in durable forms. It suggests we should be building more, redundancy into our systems, so that the failure of one part doesn't bring down the whole. It suggests we should be teaching people practical skills and fundamental knowledge, not just specialized expertise that's useless without supporting infrastructure. It also changes how we think about risk. If civilizations can collapse, if it's happened before, then we need to take seriously the threats we face. Climate change, nuclear weapons, pandemics, asteroid impacts, all the various ways our civilization could be destroyed or severely damaged. We need to plan for these possibilities, not just assume they won't happen because they haven't happened to us yet. But beyond the practical implications, there's something deeper. There's the question of meaning, of purpose, of how we understand our place in the universe. The conventional narrative is anthropocentric. It places humans at the center, with history building toward us, with us as the culmination of a long process of development. It's a narrative that makes us feel important, special, chosen. The alternative narrative is more humble. It suggests we're not the center, not the culmination, not special. We're just one more group of humans trying to survive and thrive, no different in our fundamental nature from those who came before, no more guaranteed a future than they were. This is a harder narrative to accept. It's less flattering, less comforting, but it might be more true, and there's a kind of freedom in accepting it. Because if we're not special, if we're not guaranteed success, then we have to earn it. We have to work for it. We have to make choices that will determine whether we survive and flourish or collapse and disappear. The future is not predetermined. It's up to us. And if there were civilizations before us, if they achieved great things and then lost them, then we can learn from their example. We can try to understand what they did right and what they did wrong. We can try to avoid their mistakes and emulate their successes. We can see ourselves as part of a longer story connected to those who came before and responsible to those who will come after. This creates a different kind of meaning. Not the meaning of being special or chosen, but the meaning of being part of something larger than ourselves, something that extends across time, connecting past and future. The meaning of contributing to a story that's bigger than our individual lives, that will continue long after we're gone. And perhaps that's enough. Perhaps that's all the meaning we need. To know that we're part of the human story, that we're carrying forward the work of those who came before, that we're creating something that might endure and inspire those who come after. That's what the monuments might be telling us. That's what the myths might be preserving. Not specific information about technologies or events, but something more fundamental. The message that humans have always strived to create, to understand, to leave something behind. That we're not alone in this struggle, that others have faced it before us, and others will face it after us, and that the struggle itself is worthwhile, even if the outcome is uncertain. But we need to address the elephant in the room, the academic resistance to these ideas. Why are they rejected by mainstream archaeology? Why is there such hostility to the suggestion that civilization might be older than we think? The reasons are complex, and not all of them are bad. First, there's the simple fact that extraordinary claims require extraordinary evidence. The conventional timeline of human civilization is supported by thousands of archaeological sites, millions of artifacts, decades of research by thousands of scholars. It's not just a guess or a theory. It's a robust framework built on extensive evidence. To overturn that framework, to suggest that it's fundamentally wrong, requires more than a few anomalies or unexplained features. It requires compelling evidence that can't be explained within the existing paradigm. And so far, that evidence hasn't been presented in a way that satisfies the standards of academic archaeology. This is appropriate skepticism. Science should have high standards. It should demand rigorous evidence before accepting revolutionary claims. The burden of proof is on those proposing the new theory, not on those defending the established one. Second, there's the problem of association. The idea of a lost civilization has been promoted by many people who also promote less credible ideas. Ancient aliens, Atlantis as a literal historical place, mystical or supernatural explanations for ancient achievements. When serious researchers raise questions about the timeline of civilization, they risk being lumped in with these fringe theorists, which damages their credibility and makes it harder for their work to be taken seriously. This guilt by association is unfortunate, but it's understandable. When an idea is consistently promoted alongside nonsense, it becomes tainted by that association. Academics who want to maintain their reputations are understandably reluctant to engage with topics that might make them seem less serious or rigorous. Third, there's the structure of academic careers. Researchers need to publish papers, secure funding, earn tenure. They need to work on projects that are likely to produce results that fit within established frameworks that will be accepted by peer reviewers and funding agencies. Taking on controversial topics, challenging established paradigms, pursuing research that might not pan out. These are risky career moves, especially for early career researchers who don't yet have the security of tenure. This creates a conservative bias in academic research. Not conservative in a political sense, but conservative in the sense of preferring established ideas over novel ones, safe projects over risky ones, incremental advances over revolutionary challenges. It's a bias that serves science well in many ways. It prevents the field from being overwhelmed by crackpot theories and ensures that research is rigorous and careful. But it also makes it harder for genuinely new ideas to gain traction. Fourth, there's simple human psychology. We all have a tendency to defend our beliefs, to resist information that challenges what we think we know, to interpret ambiguous evidence in ways that confirm our existing views. Academics are not immune to this. When you've spent your career building a framework for understanding the past, when you've published papers and taught students based on that framework, it's psychologically difficult to accept that the framework might be wrong. This doesn't mean academics are being dishonest or unscientific. It just means they're human. We all have cognitive biases. We all resist changing our minds. The scientific method is designed to overcome these biases through peer review, replication, and the gradual accumulation of evidence. But the process is slow and it's not perfect. So the resistance is real, and some of it is justified. The standards of evidence should be high. The skepticism should be rigorous. The burden of proof should be on those making extraordinary claims. But some of the resistance goes beyond appropriate skepticism into something else, into dismissal without investigation, into ridicule rather than engagement, into the assumption that certain questions aren't worth asking because we already know the answers. And that's where the resistance becomes problematic, because science is supposed to be about following the evidence wherever it leads, about being willing to question assumptions, about remaining open to the possibility that we might be wrong. When certain topics become taboo, when certain questions can't be asked without risking your career, when anomalies are ignored rather than investigated, then we're not doing science anymore, we're defending orthodoxy. The solution is not to abandon skepticism or lower standards of evidence, it's to apply those standards fairly and consistently, to investigate anomalies rigorously rather than dismissing them, to fund research into controversial topics so that they can be studied properly, to create academic environments where asking unconventional questions is encouraged rather than punished. Because the truth is, we don't know everything. We don't have all the answers. And the questions we've been exploring about the possibility of earlier civilizations, about the gaps in our knowledge, about the mysteries that remain unsolved, these are legitimate questions. They deserve serious investigation, not dismissal. And if the investigation shows that the conventional timeline is correct, that there's no evidence for earlier civilizations, that the anomalies can be explained within the existing framework, then fine. We'll have learned something. We'll have confirmed what we thought we knew. We'll have closed off a line of inquiry and can move on to other questions. But if the investigation shows something else, if it reveals evidence that challenges the conventional timeline, if it suggests that human history is more complex and mysterious than we've assumed, then we'll have learned something even more important. We'll have expanded our understanding. We'll have discovered something new about who we are and where we came from. Either way, the investigation is worthwhile. Either way, asking the questions is valuable, because that's what science is. Asking questions, following evidence, being willing to be surprised by what we find. And the past is full of surprises, if we're willing to look for them. So where does this leave us? What should we conclude from this exploration of lost history, ancient mysteries, and the gaps in our knowledge? We should conclude that we don't know as much as we think we do. That the past is deeper and stranger than the simple narratives we've constructed. That human history is more complex, more mysterious, more full of surprises than we've been willing to acknowledge. We should conclude that the anomalies are real. The precision stonework, the astronomical alignments, the ancient maps, the persistent myths, these things exist. They require explanation. And the explanations we've been given are often inadequate, incomplete, or simply dismissive. We should conclude that the possibility of earlier civilizations is worth taking seriously, not as proven fact, not as certain truth, but as a legitimate hypothesis that deserves rigorous investigation. The evidence is fragmentary and ambiguous, but it's there, and it points towards something we haven't fully understood. We should conclude that we need to look harder, dig deeper, ask better questions. We need to apply modern technology to old mysteries. We need to search in places we haven't searched before. We need to be willing to challenge our assumptions and revise our beliefs when the evidence demands it. But we should also conclude that uncertainty is okay, that not knowing is okay, that mystery is not a problem to be solved but a condition to be embraced. Because the sense of wonder, the feeling that there's more to discover, the recognition that the past still has secrets to reveal, this is what drives us forward. This is what makes the search worthwhile. The past is not dead. It's not even past, as Faulkner wrote. It's alive in the monuments that still stand, in the artifacts we're still finding, in the DNA we carry, in the stories we tell. It's alive in the questions we ask and the mysteries we ponder. It's alive in our curiosity and our wonder. And perhaps that's the real message from the past. Not specific information about who built what or when, but something more fundamental, that humans have always wondered, always questioned, always sought to understand. That we've always looked at the world with curiosity and awe. That we've always tried to leave something behind, some trace of our existence, some message for those who come after. We are those who came after. We're finding the traces, reading the messages, trying to understand what they mean, and someday we'll be the ones leaving traces and coding messages, hoping that someone in the distant future will find them and wonder about us. That's the cycle. That's the story. That's what it means to be human, and the story is not finished. There are still chapters to be written, still mysteries to be solved, still truths to be discovered. The past is still revealing itself slowly, gradually, offering up its secrets to those patient and curious enough to search for them. So we keep searching, we keep questioning, we keep wondering, because that's what humans do. That's what we've always done, and that's what we'll keep doing as long as we survive, as long as we endure, as long as there are mysteries left to explore and questions left to ask. The ancient lost era that scientists can't explain might remain unexplained, or it might eventually be understood, its mysteries solved, its secrets revealed. We don't know which. We can't know which. All we can do is keep looking, keep investigating, keep following the evidence wherever it leads. And in the meantime, we can embrace the mystery. We can appreciate the wonder. We can recognize that not knowing everything is not a failure, but an opportunity. An opportunity to discover, to learn, to grow. An opportunity to be surprised by what we find. Because the universe is vast and old and strange. Human history is long and complex and full of surprises. And the past, that vast expanse of time before we were born, before our civilization arose, before recorded history began, the past is not empty, it's not simple, it's not fully known, it's waiting. Waiting to be discovered, waiting to reveal its secrets, waiting for us to ask the right questions and look in the right places and be willing to see what's actually there, rather than what we expect to find. And maybe, just maybe, what we find will change everything. Maybe it will reveal that we're part of a much longer story than we realized. Maybe it will show us that we're not the first, not the only, not the culmination of history, but just one more chapter in a story that extends far back into the mists of time and will continue far into the future. And maybe that's exactly what we need to know. Not to diminish our achievements, but to put them in perspective. Not to make us feel small, but to connect us to something larger. Not to discourage us, but to inspire us to build something that will endure, to create something that will last, to leave traces that future generations will find and wonder about. Just as we wonder about the traces left by those who came before. That's the challenge, that's the opportunity, that's the message from the past if we're willing to hear it. We are not alone in time, we are part of a continuum, connected to those who came before and those who will come after. What we do matters. What we create matters. What we preserve matters. And the search for truth, the pursuit of knowledge, the willingness to question and wonder and explore, these matter most of all. Because in the end, that's what separates us from the animals. Not our tools, not our technology, not our cities or our civilizations, but our curiosity, our wonder, our endless, restless desire to understand. That's what makes us human. That's what's always made us human. And that's what will continue to make us human, as long as we survive, as long as we endure, as long as there are mysteries left to explore and questions left to ask. The ancient lost era is one of those mysteries, and whether we solve it or not, whether we find the evidence or not, whether we prove it existed or prove it didn't, the search itself is worthwhile. Because the search is what makes us who we are, and the mystery is what keeps us searching.